So we can analyze what is the ultimate capacity possible under the 2-second rule, just like we did for the follow rule. And I am using the 2-second rule because the 3-second rule is just idiotic. So the length of road effectively occupied by one car is equal to the distance traveled in 2 seconds. Since it's not a car length dependent quantity, but instead a time dependent quantity, what we're going to do is we're going to say that the space of road that a car occupies is going to be the velocity times time. And so then we can say that the density, again, is the reciprocal of that L road, the footprint. So that's going to be 1 divided by velocity times time. And in this case, our time is going to be this 2 seconds. So we can see the conversion there of 5.56 times 10 to the negative 4th hours. So that puts us into the units of density, which is cars per mile. Now, if we multiply that times velocity, remember capacity is equal to density times velocity. So if we multiply that by velocity, we're going to get V over V times our 2 seconds. Now, very quickly, we can see that we can cross cancel the V's, and we're just left with 1 in the numerator. And so now we can go ahead and just flip the fraction there, or take the reciprocal of that 5.56 times 10 to the negative 4th. So we flip that, and we end up with just a number. There's no variable left, and so we get a number that is independent of speed. It's 1,800 cars per hour is what's going to be delivered if the cars on the road are following this 2-second rule. So it doesn't matter if the cars are traveling 10 miles per hour or if they're traveling 75 miles per hour. If they're observing the 2-second rule of that amount of space between cars, the capacity is always going to be this 1,800 cars per hour. So in our last example here, we've got this circumstance where the 5,000 citizens of Saratoga that travel to the state capital, Albany, during this 1-hour period of time in the morning in single occupancy vehicles. We want to know how many lanes of traffic are necessary if they're going to use the 2-second rule or if they're going to use the follow rule at 50 miles per hour. So for the 2-second rule, we just found that it doesn't matter how fast the cars are traveling, the capacity is going to be 1,800 cars per hour. And so if we want to figure out how many lanes we need, we can just take that 5,000, divide it by 1,800, and so we're going to get, rounding off to the next upper integer, because we can't round down, so we need 3 lanes. We can see that 1,800 times 2 is going to get us to 3,600, times 3 will get us to 5,400. So we're going to need 3 lanes if we're following this 2-second rule. We'll have excess capacity with 3 lanes, but we need 3 lanes. For the 50 mile per hour follow rule scenario, so in that case, we have to figure out what the capacity is. So we've got our equation for that, which is V over, and we'll assume that the car has that same length that we did earlier, 0.0025 miles, times 1 plus V over 10, since the footprint is going to depend on the velocity. So plugging in, we end up with a velocity of 50 miles per hour on the top. We've got 0.0025 miles times 1 plus, and then 50 divided by 10. So eventually we're going to end up with a capacity of 3,333 cars per hour. And that's per lane. So again, if we take that 5,000 that we need to get from Saratoga to Albany, divide that by the 3,333, we can see that we're going to end up with only 2 lanes that are going to be necessary. We don't need the 3 that we need on the 2-second rule. We can get it done in just 2 lanes. So depending on what rule we're following and expecting the traffic to follow, that impacts our required number of lanes to deliver those 5,000 individuals.